Now, adding this getter to expense bucket is one important step I want to take before we start creating the actual chart. The other thing I want to do here, I want to add my own alternative named constructor function, which can be done by repeating the name of the class, expense bucket, and then adding a dot right after it inside here of the class definition, and then adding the name of the extra constructor function you want to add to this class. Like in my case here, for category. That's the extra name I want to use. And this is how you can add additional constructor functions to your classes. And this is, of course, a feature we used from time to time in this course. For example, here on edge insets symmetric, where we create such an edge insets object by using the alternative symmetric constructor function. This here is how you can define your own alternative constructor functions, alternatives to the default constructor function. So what's the idea behind this alternative then? Well, my idea here is that I do get a list of expenses here, which could be named all expenses here. So this is simply a parameter accepted by this constructor function. So we expect to get a list of all expenses here from all categories. And I also want to get a second argument, which sets the category, which is one of the properties I do want to set here. And now the idea behind this extra constructor function is that we add some logic to this constructor function to go through all the expenses we got and then filter out the ones that belong to this category so that we can set the expenses for this expense bucket, which is tied to one specific category, to a list of expenses that only are for that category. So this is simply a utility constructor function that takes care of filtering out the expenses that belong to a specific category. Now, to set this expenses property to the expenses that have this category at the point of time this constructor function is called, we have to add a so-called initializer list by adding a colon after our constructor function parameters here, so after this closing parenthesis. And then here you can set expenses, so this property here, equal to all expenses, so this list of expenses we're getting here, and then filtered for the expenses with this category. And this can be done with help of the built-in where method. Now this is a method provided by Dart, which is available on all lists, and where is simply a method that allows you to filter a list. It takes a function as an argument, so you pass a function here as an argument to where, here an anonymous function using this arrow notation. And then you automatically get your individual list items as input. So here I get a single expense, since this function is executed on all the expense items in all expenses. So every time it executes, I get one single expense. And here we have to return true if we want to keep that expense in the filtered list, or false if we want to get rid of it. And here, of course, I don't want to hard code true or false. Instead, I want to derive true or false dynamically by checking whether the expense I'm currently evaluating here has a category that's equal to this category here. So to the category property of that class. So if the expense I'm currently taking a look at has the category I want to set for this expense bucket, I want to keep that expense in that list of expenses that is stored in this bucket, otherwise it should be dropped. That's what we're saying here. And now we just have to make sure that we convert this back to a list. And here we have to check with a double equal sign, because a single equal sign tries to assign a value, which is not what we're doing here. With a double equal sign, we check for equality, which is what we want to do here. And with that, we got this utility constructor function in place, which we will soon use to create the different buckets that are represented by chart bars in our chart.